Hello everyone, in the previous video I had checked if we have to take into consideration the orthogonal effect in our model and how to take it in the static analysis. We will be back to this point after running the analysis in Etabs to check type 1 torsional irregularity. I will put the link in the description. In this video we will define load combinations. Define load combinations. For this project we will use the strength design method as we see in section 1612.2.1 in UBC. You can use the strength design method, so you have to apply these load combinations. But before applying these load combinations, I will check the exceptions. Exception number 1, where load combinations do not include seismic forces. Go to this section, use this load combination, U equal 1.4 dead plus 1.7 live. This is the first load combination in vertical loads. Go back to page number 4. The second exception, multiply by 1.1 for concrete and masonry where load combination includes seismic forces. We have concrete building, so we will apply these two load combination with 1.1 because we have a seismic loads and these two load combinations, and we don't have earth or temperature, or we will talk about temperature later, and the water loads. That's it for exceptions. F1 for garage and life loads or any life load that exceeded 4.9 kilonewton per meter square, F1 equal 1 and equal 0.5 for other life loads, so F1 in our case equal 0.5. and F2 we don't have roof, any special roof loads, so we will ignore F2 for this project. Okay, vertical loads 1.4 dead load plus 1.7 life load. 1.4 dead, we will take it as it is, 1.4 dead, and 1.2 dead, 1.6 live, and 0.5 live for roof or live for snow. If you define the special live for roof and define the snow, then you will divide this load combinations into two load combinations: dead live plus snow 0.5 snow and dead live plus 0.5 roof. For this project we don't have snow and we didn't apply a special loads for roof, so we included this roof life load in the normal load, so LR is included in L, so we will not take this term into consideration. So this is the load combination we will define in Etabs. Go back to this file. How to apply these load combinations due to load patterns we had defined. You can check define load pattern video. I will put the link. 1.4 dead, you can name it 1.1 U dead and apply 1.4 dead plus 1.4 dead super. Dead live, you can give it this name and apply this load combination. I will apply this load combination only because it's the worst case. This load combination will get or will give larger values more than these two load combinations, so I will apply this load combination only. You can apply it, but I will apply only this load combination: 1.4 dead, 1.4 dead super, and 1.7 live. Go in Etabs, define load combinations, add new. I will apply this load combination. I'll give it this name, add linear, and we'll apply this load combination: 1.4 dead, 1.4 dead super, and 1.7 live. Okay. Wind load combinations, as we see in code, we find wind in these three load combinations. First load combination: 1.2 dead plus 1.6 live for roof. We did this mistake, and this project we didn't assign special life load for roof, but it's very small, so I will ignore it. In other projects we have to assign special life load for roof. We don't have snow, so we will ignore this term. First load combination, because we have or, so first load combination: 1.2 dead plus 0.5, as we said for our project, f1 equal 0.5 live. In the previous load combination we took 1.4 dead plus 1.7 live, so the previous load combination is the critical or the worst case, so I will not take this load combination into consideration. So the load combination now is 1.2 dead plus 0.8 wind load. All before every or before all wind or seismic loads and load combinations, apply plus and minus, because you don't know the direction that the wind will be applied in reality. So take plus and minus, go to so the wind load will be 1.2 dead plus and minus 0.8 wind. So in Etabs we will take first load combination: 1.2 dead plus 0.8 wind, and we will take 1.2 dead minus 0.8 wind load. The second load combination in code: 1.2 dead plus 1.3 plus and minus, as we said, plus and minus and plus and minus, 1.3 wind plus 0.5 live. We don't have snow here. 0.5 live for roof, it's included in this term, so we can delete this. 1.2 dead plus minus 1.3 wind plus 0.5 live. We can see it in this note: 1.2 dead plus minus 1.3 wind plus 0.5 live. We will see how to apply these on our load patterns. The last load combination for wind loads: 0.d plus and minus 0. Wind. We will take this load combination while assigning the seismic load combinations. So it's now 0.9d plus and minus 1.3 wind load. So now the first load combination: 1.2 dead and dead super 1.2 plus 0.8 w and minus 0.8 w. The second load combination: 1.2 dead, 1.2 dead super, because it's dead load, and 1.3 plus 1.3 wind plus 0.5 live, and minus 1.2 dead, 1.2 dead super, minus 1.3 wind load plus 0.5, and the last load combination 0.9 dead plus and minus 1.3 wind load. Now we have to apply these load combinations in Etabs. So in Etabs, add a new combo, copy P for positive, copy this name, and apply these factors. 1.2 dead plus 0.8 wind, 1.2 dead and 0. Dead and 0.8 wind. Okay, and add copy, and for negative, and put minus here. Okay, this is the first load combination. Second load combination, copy this name, 1.2 dead, 1.3 wind, 0.5 live. Okay, add a new (1.2) dead, dead super, 1.3 live, wind, and 0.5 live. Okay, add copy, and for negative, and put negative sign. Okay, last combination, 0.9 dead super, and 1.3 wind. Add new 0.9 dead super, 0.9, and 1.3 for wind. Okay, add copy, and N for negative, put the minus. Okay, and save your work. Seismic load combinations. If we see in the code, we have these two load combinations. For earthquake, we created the wind load combinations. We don't have snow for loads on our project, so the first load combination will be 1.0 dead load plus and minus 1 earthquake plus F1, as we said before, 0.5 live load. What is E for in this load combination? We have to go to page 13, section 16, 33.16.1. E equal rho for this project equal 1, so we will talk about rho later. EH, the horizontal force of the earthquake. In static procedure, when you select EQ, the static load pattern we had defined before, the software will calculate EH plus EV, so you have to take into consideration the vertical component of the ground motion of the earthquake. What is EV? You have to take it in plus and minus because you don't know the direction of the wave. EV for the static analysis will be a percentage of the dead load, 0.5 CAI dead load. So the first load combination will be, as we said, E equal rho equal 1, so EH plus EV 0.5 CAI D and plus 0.5 live. So the first load combination will be, if we get, or if we move this term or this factor of dead load, the first load combination plus and minus will be 1.2 plus and or plus or minus 0.5 CA I times the dead load plus and minus EH, because rho in this project equal 1, and plus 0.5 because F1 equals 0.5 live load. We can see this in note. And the second load combination, as we see, 0.1 0.9 dead plus and minus 1 E, as we said, EV will be 0.5 CA I time dead load times dead load plus and minus 1 EH, and this is the second load combination. So we have these two load combinations that we have to apply them onto our model in Etabs. I will not apply all of these load combinations. I will apply only, or I will insert only load combinations with this red star. As we see, we have two load combinations, but first we know that we design our columns or shear walls due to two worst scenarios. First scenario, we search for the largest vertical or gravity load with moment, and second scenario, we search for the largest moment with the smallest vertical load. From these two load combinations, in my opinion, we will get the largest vertical or gravity load from this load combination, 1.2 plus, not minus, plus 0.5 CAI plus F1L. We will get larger values from 0.9 plus 0.5 CAI without adding any live load. So I will not use the plus sign in this load combination. As we see, I will not use this load combination and this load combination with the plus sign. This 0.125 is 0.5 CAI. CA, we got CA from tables. You can check define load pattern video, and I equal 1. Okay, and the second worst case, the maximum moment, we have the same moment. We'll get moment from the seismic forces, so we have same moment for both cases, for both load combinations. So we will get the smallest or this worst case from this load combination. We will get the smallest vertical load from 0.9 minus 0.5 CAI D. We will get smaller value from smaller than the vertical value from this load combination, 1.2 minus 0.5 CAI D plus F1L. So I will not use the minus sign and for this load combination 3.5. That's why I will not use this load combination. Okay, and that's it. That's why I will not use these 4 load combinations. What about the exception 2 in UBC code? We have to multiply all load combinations with the seismic forces by 1.1. So I will multiply the first load combination with 1.1. I'm sure that I will get larger vertical or gravity value by multiplying it by 1.1. That's why I multiplied this load combination with 1.1. 0.5 times 1.1 equals 0.55, and minus h, so I get minus h. We have these two load combinations. For this load combination, I'm not sure that I will get the worst case from multiplying this load combination by 1.1, so I will try or insert in Etabs both solutions by multiplying this load combination by 1.1 and multiplying it by 1.0 by 1. Why I will do this, I will try these two solutions because maybe the worst case will be when we multiply the moment by 1.1, but we don't want to forget that the vertical load will be multiplied too, then we will get larger vertical load, and when we multiply it by 1 we will get smaller load but smaller moment. That's why I will try both solutions, one with multiplying the load combination with 1.1 and without multiplying it, for plus and minus EQ. So now we have these two load combinations for the first load combination, and we have these four load combinations for the second load combination. We have to apply these onto Etabs. For sure you can always insert all of these load combinations, but this would take too much time. I will start with this load combination, copy. I'll copy the name, you can name it, give it any name, define load combinations, add new, paste the name and apply the load combination. 1.1 times 1.2 plus 0.5 CAI. So I will copy this factor and paste it here, put the multiply sign, and that's it. Add copy for the dead super, earthquake EQ 1.1, and for live load 0.55. okay, same load combination with the negative sign for earthquake, because we don't know the direction that the earthquake will be applied in the reality. Add copy, just change the sign. Okay, now for load combination 3.6, go copy this load combination, add new, copy this factor, one for earthquake, add copy, just change the sign for earthquake. Now the same load combinations but multiplied by 1.1, so add copy, you can get the factors from here or just multiply it by 1.1. Times this load combination, add copy and copy the last load combination, change the factor, the sign. Okay, as I said, you can always add all of these load combinations, but this will take a lot of time, and that's it for this video.